All right, finally, a short set of notes. Here we got the unit. This is Unit 8, actually. This is just an old set of notes. Unit 8, Objective 6, more radian measurements. Okay, so today's lesson really involves two identities which originate with the statement that 180 degrees equals pi radians. So kind of the same thing we were talking about in the last section. Okay, so basically here what we're going to learn how to do is convert from degrees to radians and then vice versa from radians to degrees. Okay, so first of all, what does 1 degree equal? Okay, so how can we write 1 degree? Well, I know that 1 degree, and this is going to sound silly, like a silly way to write it, but since we know that, let's do it this way. I know that 180 degrees equals pi. Okay, well, I don't want 180 degrees, I want 1 degree, so how can we get that? Well, what if we divide by 180? If I do that on both sides, well, then this gives me 1 degree, which means this also must give me 1 degree, because again, these two things were equal to begin with, and we divided them both by the same thing, so then that means that this must equal 1 degree because this equals 1 degree. So 1 degree equals pi over 180. All right, and this is going to help us convert from degrees to radians and vice versa. Okay, let's look at it from a different perspective though. What is 1 radian? Okay, well I know that 180 degrees is pi radians, so again we're kind of sticking with that same definition. And we can even spell it out, it's pi radians. Okay, and then if we want 1 radian, so focusing on this side of the equation, here we have pi radians, so a little more than 3 radians. Well, to get 1 radian, I want to divide by pi. Probably should have done it in red. Oh, it doesn't matter, stick with blue. If I divide both sides by pi, well then that means that 180 over pi equals 1 radian. Okay, because again, 180 is pi radians. Okay, so that's a little bit more than 3 radians. Well, if I divide by pi to go from a little bit more than 3 to 1, well then this gives me 1 radian, which means this must also equal 1 radian. Okay, now if that's not 100% clear, not a huge deal. Basically, this is what we need to know. How do we convert from degrees to radians? Well, if I have degrees and I want to put it in radians, I want to multiply by pi over 180. Sorry, hopefully you can read that. Multiply by pi over 180. And if I want to convert from radians to degrees, what do we do? Well, we multiply by 180 over pi. Okay, now to help you memorize, which one you need to do. If you want to go from degrees to radians, where do you want pi to be? Well, you want pi to be in your numerator, and you're going to have some other number in your denominator. You're going to create that fraction, right? And if you're going from radians to degrees, well, radians, you're already going to have a pi in the numerator. You're going to want that pi to cancel, so then you're going to want to multiply by something that has pi in the denominator. Okay, so that's kind of how you can think about it, is where do I want the pi to end up? Do I want it to cancel? So do I need to put one on the bottom to cancel with what I already have? Or do I need to introduce pi to my numerator and multiply by pi over 180? Okay, now, these will both work. Probably an easier method for converting from radians to degrees, though. So I'm going to put slash because you can do either one. Just substitute 180 for pi. Okay, because if I have something written in radians, let's zoom in a little bit, like our first example. All right, so they said, what is the equivalent of 7 pi over 10? So they gave us an angle in radians. We want to get it in degrees. Well, yeah, I can multiply by 180 over pi, okay, because that's just multiplying by 1, which is not going to change my statement. It's not going to change the value of my angle. And then that would get the pi's to cancel. Awesome. Okay, but probably a little bit easier is let's just stick in what pi equals. Well, I know pi is the same as 180 degrees. Let's just plug in 180 degrees there, and then we can simplify that. Okay, so on this problem here, let's scoot over so we can use as much space as we need. We're starting with 7 pi over 10. Okay, and then I want to convert that to degrees, so then I'm going to substitute in 180 degrees for pi. So then this is the same as 7 times 180 over 10. Okay, and then now I just need to simplify that, and I'll have my answer. Well, let's see. I can divide top and bottom by 10 here. That's going to knock the 0 off the 180, and that's going to make that a 1. So basically it gets rid of my denominator. And then that leaves me with 7 times 18, which is 126. So 7 pi over 10 is the same as 126 degrees. So there's our answer. Okay, so again, we could have said, all right, I want to multiply by a version of 1. So I could have taken my original angle, multiplied by 180 over pi. That would get the pi's to cancel, and I'd be left with the 180 on top instead of the pi. Well, it's pretty much the same thing as substituting in 180 for pi. So that's what I think is the easier way to do it. Whenever you want to switch this to degrees, just plug in 180 for pi. Okay. All right, next, what is the equivalent of 250 degrees? And we want to write this one in radians. So this one is a little bit different. Here we can't just use substitution. Here we actually do have to multiply. So we're starting with 250 degrees. Okay. Let's see. That's the same as 250 over 1, just so we have a fraction. And then I want to multiply by something. Now again, since we're starting off with just a statement, there's not an equation. I know we have an equal sign here because these two things are equal. But we're starting off with just an angle. I can't, multiply both sides of my equation. There is no two sides of my equation. So really all I can multiply by is 1. But we can be clever with how we write 1. Okay, so I want this thing written in radians. Well, radians has a pi on top. So I need to multiply by something with pi in it. And then we'll pi over 180. That's one way I can write 1, because again, this thing equals 1 like we showed before. Okay, so then this is how we're going to convert this to radians, and then I just want to simplify. So what is 250 over 1 times pi over 180? Well, multiply the top straight across, we get 250 pi over 1 times 180 is just 180. And then, well, let's see, these both end in 0, so if I divide top and bottom by 10, well, I knock off the zeros, and we end up with 25 pi over 18. And then that's my answer in radians. So this angle is the same as 250 degrees, which is what we started with. Okay? All right, so we're not going to do a bunch more examples. It's pretty straightforward. Anytime we're converting from radians to degrees, just stick in 180 for pi. Anytime you're going from degrees to radians, well, then we want to multiply by pi over 180. Okay, and that's pretty much it. All right, let's zoom out a little bit. And then the last part of the worksheet down here, we're just going to practice something we've already done. We're going to fill out a little half sheet, which we're going to kind of use as our cheat sheet on our test eventually. All right, so we're given SOHCAHTOA. Great, we got that. And then we got a little axis here. Okay, well, where are each of our trig functions positive? Well, remember, all students take calculus. So they're all positive in quadrant 1. Sine is positive in quadrant 2. Only tangent's positive in quadrant 3. Only cosine is positive in quadrant 4. All right, and then we got sine, cosine, and tangent. What are those equal? Well, we got it right there. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But what are the other definitions of sine, cosine, and tangent? Okay, now again, if you forget, then just grab a piece of scratch paper and draw a little axis, and then draw a triangle. And say, okay, normally this is my opposite side of my angle here. Well, now this is how far up and down I'm going. Those are my y's. This is normally my adjacent side, how far left and right I'm going. Well, that's my x's. And then in the unit circle, this would be my radius in the unit circle. So my hypotenuse is now my radius. Okay, and then now I can replace the definitions of SOHCAHTOA with x's and y's and r's. And when we do that, well, we get sine is y over r, cosine is x over r, and tangent is y over x. Okay, these definitions will always work for sine, cosine, and tangent, and they are the only ones that work when we're dealing with quadrantals. In other words, when we have a point on the x or y axis in our unit circle. Okay. All right, next, degrees to radians. These are just some of the more common angles that we're going to see. The most important one is the second one here. 180 degrees is pi radians. If you know that, you should be able to figure out everything else. Okay. Well, double this, we get 360 degrees, so double that, we get 2 pi. Cut this in half, we get 90, so cut this in half, we get pi over 2. And then let's see, 60 degrees, well, that's 1/3 of 180 degrees. So then this is going to be 1/3 of pi, so pi over 3. 45 degrees is 1/4 of 180 degrees. So then this would be pi over 4. 30 degrees is 1/6 of 180 degrees. So then this would be pi over 6. Okay, so then here's some of our more common angles written in radians. Okay, and then the last thing we want to fill out is our special right triangles. So these are important. We use these a whole bunch. This looks like the smallest angle. We'll call that our 30-degree angle. We'll call this our 45-degree angle down here, looks like. And I think this is our 60-degree angle. Okay, and if this is our 30-degree angle, what are the sides of that triangle? If we plug in A as 1, well, it's going to be 1, 2, and root 3, which is the same in this triangle, just reoriented. It would be 1, 2, and root 3 there. And then the 45, 45, 90, our sides are 1, 1, and root 2. Okay, so all of this stuff is something that before we take the test, you should be able to fill out by yourself. Okay, anyways, that's our set of notes. Nice short one today, and that's it.